Hello guys, welcome back to my channel. Today we're going to be looking at question 5 and 6 in the January 22 CXC Mathematics past paper. Now please notice in my previous two videos I did question 1 and 2 and I did 3 and 4. So we're now on to 5 and 6. It says the cumulative frequency diagram below shows information about the distance d kilometers that each of 120 students walk to school on a particular day. Now examine the graph for just 10 seconds. On the y-axis, you have the cumulative frequency, and on the x-axis, you have your distance. And in total, we have 120 students, which is your cumulative frequency. Alright? That is important to note. Now let's go to our next page. But I think before we go to our next page, there's actually a question on this page that says, how many students walk at most 1 kilometer to school on that day? At most 1 means 1 or less. Alright? It can be 1 or it can be less. That is what at most means. So the smart thing to do here is to come to your axis. You're going to find 1 kilometers on the x-axis and you're going to go all the way up to your graph. Once you get to your graph, you're going to stop and you're going to go across. Now right here, this is going to give me, if I'm looking carefully, I'm going to get 38. Now once you get to your graph, you have to stop. So I'm going to get 38. Now 38 students at most. Alright? It can be that or less. At most. So here, I'm going to go down now and I'm going to write that down there. So let's go. So how many students walk at most 1 kilometer to school? It's simply going to be 38 students, sorry. Now, how do I read the scale here? If this is 30 and this is 40, if you count, you notice you have 10 little lines there. So 40 minus 20 is going to give me 20. So since I have 10 little lines, each of these little lines represent 2. So technically, I could say that I have 30 right here in the middle. So you know you're going to have 32, 34, 36, 38, 40. That is how we work it out. Now if I go to my next page, it is asking me for the median. Now before I can find the median, I have to talk about the position of the median. So position equal. Now the median is halfway. It's always in the middle. So we're looking for the median distance. Now we use a cumulative frequency. And the formula for the position is simply n over 2. Where n is the cumulative frequency. Now in this particular question, the number of students you have overall is 120 and you divide that by 2. That is going to give you 60. So you're going to go back to your graph, go previous, I'm going back to my graph. I'm going to find where 60 is on the cumulative frequency. I'm going to come across the graph. This should be a little bit up. Alright, let me try to get this as best as possible. So carry this down a bit. Alright, let's go back. So we go across on 60. Alright, very good. Now once we get there, we're going to go down. As you can see here. Now, the x-axis can be a bit tricky. Notice from 1 to 1.5, you have 0.5 kilometers. So that's 0.5 kilometers you have between these 2 points here. But you also have... So each little line represents 0.05. Right, so when I'm counting now, when I'm at 1, the next little line that you see is going to be 1.05. Then of course after 1.05 comes 1.1, 1.15, 1.2, 1.25, 1.3. Good? So this is going to be 1.3 kilometers. But you don't have to stress yourself like that. Since you can go up by 0.0 or by 0.1, why not count by 2 lines? So you have 0.5, you have 2 lines, 0.6, 0.7, 0.8, 0.9, and then 1. Or you can go by the little lines if you might get confused. So let's go up by 2. I went up by the little lines. Let's go up by 2 of them. So I have 1, I have 1.1, 1.2, 1.3, 1.4, 1.5. So it's 1.3. So let's go to the next page. So the median, which I'm going to call Q2, is equal to 1.3 kilometers. Good to go? Now the lower quartile, there are 3 things you need to remember. Lower quartile, which is a quarter, upper, which is 3/4, and the median, which is a half. So the position again, position is equal to a quarter times n, which is a quarter multiplied by 120. 4 into 4, 1. 4 into 12, 3. So that's 30. So that's a position. And we're going to find that position on the y-axis, or the cumulative frequency axis. Alright, so let's pull this down here. Well, so notice we even put it on already because we don't even use it to estimate. So I'm going to go to 30. I'm going to go right across here. Once I hit the graph, I stop. And then I'm going to go down. Alright, good. So if this is 0.5, you're going to have 0.6, 0.7, 0.8, 0.9 kilometers. So let's go. So this is going to be 0.9 kilometers. Do not leave off the unit. Now the interquartile range is simply equal to the upper quartile, which is Q3, minus the lower quartile, which is Q1. Alright, so I need to find Q3. So I'm going to start with the position. Now the position is just equal to 3/4 times n. If you want, you can pull up this into your calculator too. So it's 3/4 times 120. Alright, remember we worked this out already. 30. 3 times 30 is 90. So if I find 90 on the y-axis, then I can find Q3. So let's go back to the previous page. Alright, so I need to pull this down then. Let's pull this down right here. Alright, good to go. Now if 80 is right here, 90 must be halfway. So we're going to go right across here. Once we touch the graph, it's time to go all the way down. So let me go. It's really going all the way down, you know, but because it's a bit awkward to draw. But depending on what I'm drawing with, that's why I did it like this. Alright, so I can meet it right there. Not exactly perfect, but you get the concept of it. So the idea is this: if this is 1.5, and then of course, this would be 1.55 because each little line represents 0.05. So this is 1.55. So I'm going to go to my next. Q3 is 1.55 kilometers. And so therefore, let me get some space here. The interquartile range, please do not write below the line. It's simply, let me just space this up. It's going to be equal to 1.55, and I'm going to take away 0.9. Now, if you don't like to work with decimals, simply pull up your calculator. And you're going to put in 1.55 minus 0.9. Alright. That's 0.65 kilometers. Now, please do not leave off the unit. Leaving off the unit would make you get the question wrong. Alright? So you have to be smart in how you approach the questions. Now, you can use, if you're unable to read the graph, if you use my method to work out what each line represents, then you can't go wrong. Alright? Now, question C, it says a student is chosen at random. What's the probability that the student walk for more than 1.5 kilometers to school? Now, since it's probability, we can set up a nice little thing. Probably that the distance is greater than 1.5 kilometers. This will simply be equal to the number of persons who walk more than 1.5 kilometers over the number of persons in the sample space. Now, in maths, the sample space refers to the total amount of persons that we have. So let's go back and find out how many persons walk more than 1.5 kilometers. Let's go back to the graph. Let's find 1.5 kilometers on the graph. If I find 1.5 kilometers, it's going to go up. So here's a line, we go up on that line. I'm just going to use a freehand so we can get it done quickly. Here's 1.5 kilometers. Alright, so we'll go up on this bold line here, we can't miss it. And we'll get to this point right here. Now if I look very carefully, let me make sure I'm looking very carefully. Okay. So it goes all the way up on this line. I think it goes right here, right to this point, and then they come right across right here. Alright, I'm using freehand here, so but you use your ruler to get it. Now, please bear in mind that each of these lines represent 2, so that's going to be 82. So let's go back to the previous page now. Next. So we find out that 82 persons walk 1.5 kilometers or less, but we want to find out how much walk more. Remember, you have 120 persons in all, and you have 82 persons walking what? 1.5 kilometers or less. But you want more, so you have to subtract. So it's 120 minus 82. Now, once again, as I say, you don't have to make mistakes. You can simply plug it quickly into your calculator. You have 120 minus 82. That's 38, alright? Because persons do panic in exams. So I'm going to have, let me put this back in bold here. Let me change the color. I'm going to have 38 over 120, which we can break down. I'm going to pull up my calculator here. Fraction bar, 38 over 120. You press equal and breaks it down for you. So you get 19 over 60. That is your probability. Right, good so far. Let's go to the next page. It says complete the table below using the information to calculate an estimate of the mean distance walked by the students on that day. Alright, fair enough. Now, if you look here, first you have midpoint, you have the distance, you have the midpoint, you have the number of students, and you have fx. The midpoint means you basically add the lower boundary to the upper boundary and you divide that by 2. So if you look at the pattern right here, there's always a pattern in there since they're doing it. You have 0.25, 0.75, 1.25. So what do you think is going to come next? Look down here, 2.25, 2.75. So it must be 1.75. If you feel uncomfortable with that, you use a calculator. I'm going to pull it up. You add the boundaries that are here. So on calculator, you're going to have 1.5 plus 2 all over 2. That's how you get the midpoint. You divide by 2. So you add the boundaries and you divide by 2. That's how we get 1.75. Now, let's go to the other part now. The number of students. What I'm going to have to do here is to reverse the cumulative frequency. Good. Now, please bear in mind that on the x-axis, you have the upper boundary. And on the y-axis, you have the cumulative frequency. So to get any respective frequency, you have to subtract 2 respective cumulative frequency. What do I mean by that? Alright, to get the value here, I'm going to have to find the cumulative frequency for 1.5. I'm going to have to find the cumulative frequency for 2. And I'm going to have to subtract them to get the frequency. Because remember, they will have come by the cumulative frequency by adding the frequency each time. So let's go back to the graph. We're looking for 1.5 and we're looking for 2. Alright, 1.5. Here we go. 1.5 is 82. Alright, the cumulative frequency, I remember we found that. The cumulative frequency is 82. Alright. And we're looking for 2 as well. If we go up to 2, we go up to the graph right here. And then we come across like that. Notice this is 100. This is 110 right here, so this must be 112. So it's going to be 112 minus 82. That's how you get the frequency. The frequency is what you get when you subtract 2 consecutive cumulative frequency. Alright, once again, if you feel uncomfortable with this, never fear to use your calculator. Alright, so you're going to put in 112 minus 82. Now you might not need a calculator, but persons get nervous in exams. So let me go back. So this right here is going to be 30. Now, we do the same thing. the upper boundaries here are 2.5. So we're going to have to find 2.5 and 2. But the good thing is that we found the value for 2 already. So let's go back. The value for 2 was 112. So I need to find the value for 2.5. So I know I'm going to subtract 112. 2.5, I go all the way up. And this is just too short of 120. Because notice if you come across, this is where you end up, right? That's going to give me 118. So it's going to be 118 minus 12, which is going to give me 6. So let's go to the next page now. And we're going to put in our 6. Alright, now, does this make sense? Let's check. Remember, the total number of persons you have is 120. If it doesn't add up, something is wrong. So let's go 12 plus 24 plus 46 plus 30 plus 6 plus 2. If I don't get 120, I'm in trouble. I got 120, so I can relax, right? Now, frequency. Bear in mind, this is your frequency. This is your midpoint. So all we need to do is to put the frequency times the midpoint in the calculator. So, frequency times midpoint. So 1.75 times 30. 1.75 times 30. Alright, S to D, change it from a fraction to decimals, 52.5. So I'm going to have 52.5 here. And then I'm going to have 2.25 times 6. Once again. So on 2.25 times 6, S to D, 13.5. Good. Now they want us to find the mean. The mean, which is represented symbolically as x bar, is equal to the sum of fx over the sum of the frequency. Let's pull this down a bit. You have fx already. This is your column. So technically, all you have to do is to sum it up. Sum of fx equal. Now that's a job for your calculator, of course. So you're going to and you're going to have 3 plus 18 plus 57.5 plus 52.5 plus 13.5 plus 5.5 equal 150. So this is 150. So I'm going to have 150 divided by 120. And of course, do not clear your calculator because you have the value in there already. You just need to put divided by 120 persons that you have. Alright, you get it to decimal. That's 1.25. What's the unit again? Kilometers. Do not leave that off. And that is how we complete that question. Let me go down a bit and see if I'm missing out anything. No, that's 3 marks for you. Alright, so you just need to focus and do it. Question 6. Here we go. At a track meet, a cylindrical container fitted with pipe as shown in the diagram below is used to serve water to athletes. The cylindrical container of radius 12 cm and height 20 cm is completely filled with water, so it's filled. And the pipe filled at the bottom dispenses water into a cone-shaped cup. The cone-shaped cups have a radius of 3 cm and a height of 8 cm. And typically, at track meets or at football match, you do normally have these kind of cups, alright? You normally have an igloo that does look like a cylindrical container. So pretty much it captures some amount of real life here. Alright, now here's some piece of information that is very useful. 1000 centimeter cube is 1 liter. Calculate, now we are imagining that the walls of the cylinder or the walls of this cylindrical container, the thickness is negligible. Notice they don't account for that, so you ignore that completely. Calculate the volume of water in the cylindrical container in liters. Don't worry about liters yet, worry about the units that you have. So you need to ask yourself, what's the formula for the volume of a cylinder? Alright, I'm supposed to write down here, but so you can see it and so you can see the cylinder right up here. The volume is equal to pi r squared times height. Alright, now volume is equal to pi, which is 22 over 7, times r squared, which is the radius squared, so that's going to be times 12 squared, times the height, which is 20. Alright, now guess what? Your calculator is such a useful instrument because that is what it's going to do all the work for you. So you're going to have your 22 over 7 times r squared, so times 12 squared, times 20. Alright, so you're going to have 9,051.43. 9,051.43. But why 0.43? Because it did say to 2 decimal places. Now, if you look inside of your calculator, you have 42, but if you look after the 2, you have 8. So you're going to have to go around one position up. Now, the unit here would be cubic centimeter. You don't want that. They say 1,000 cubic centimeter equal 1 liter. So I need to convert this into liters. So I'm going to divide this by 1,000. Now we can use a typical thing that we do. Cross a 0. Cross an x 0. Cross an x 0. Alright. So correct to this. Oh, they want it in liters to 2 decimal places. That is what I should have said initially. So here it's going to be 9.05 liters. Alright, so the answer that you wanted was for the liters, not necessarily for the first part. So that's me rounding off. Why I get 9.05? Because after the 5 comes 1, and anything below 5, you don't round up. So you have 9.05 liters. Alright, not bad so far. Let's take it down. Alright, we're going to have to go to the next page. Here we go. Alright, water flows from the cylindrical container along the pipe into the cone-shaped cup at a rate of 7.8 milliliters per second. So every second, this amount of water goes into the cup. Now, it is also important that we know that 1,000 milliliter equal 1 liter. Alright? Also, 1 centimeter cube is approximated to be 1 liter. That is important as well. Calculate the time taken to fill one of the empty cone-shaped cup, giving your answer correct to the nearest second. If I'm going to calculate the time it takes to fill one, I would need to know how much one holds. So the volume is equal to 1/3 pi r squared height. So let's go back and look at it. The radius of this cone is 3 and the height is 8. Right. So it's going to be 1/3 times 22 over 7 times 3 squared times the height, which is 8. So the volume equal, let's go back now to the calculator. So I'm going to have 1, you can press 1 the fraction bar, then 3. So times 22 fraction bar 7 times 3 squared times 8. Alright, in decimal 75.43. So that's 75.43 cubic centimeters. Alright, now in milliliters, it's also the same thing as saying 75.43 milliliters. Very important assumption that we made there. So what do I do then? If this is the amount that the cup can hold, and this is the amount that goes in every second, how do I find the amount of time it takes to be filled? I just need to find how much of this can go into this. So time will simply be equal to 75, okay. So it's a 75.43, which is how much it can hold, divided by how much goes into it every second. That will give me the amount of seconds, 7.8. Calculator work, alright? So let's go for it. Where are you? Alright, so I'm going to have 75.43 divided by 7.8 equal. That's 9.6. And it says to the nearest second. Now, since you have 9.6, 6 comes after 9, which is more than 5. You round up one place, so 9 goes up to 10. So it's going to be 10 seconds. Alright? Now, let's go down a bit now. Determine the number of empty cone-shaped cups that can be completely filled from the cylindrical container. Alright, the number that can be completely filled. So, you have several ways to work this out. We can either convert, so we need to have the two units, right? So it's the volume of cylinder. Let me just draw the cylinder. All over the volume of the cone. Because you need to know how much cylinder can literally need to know how much cones can go into the cylinder. And since you're saying how much can go into it, that means you're going to divide. So you see how we can use logics and real life together? How much of this can go into this? That means you're dividing. And it wanted completely filled. Now, this is very interesting now. Alright, so guess what? We have, if I go to the previous page, I have both of them in cubic centimeters already. So there's no need for me to convert 1 to liter or 1 back to milliliter. That would be a waste of time. On this page, we have the volume of the cone, which is 75.43. On the previous page, we have the volume of the cylinder. Let me go previous, which is 9,051.43. So 9,051.43. Once again, this is one for the calculator. Alright, so I'm going to have 9,051.43 divided by 75.43 equal. Now this gives me 119.99. So 119.99. So 119.99. Now technically you use reasoning in this. And it keeps going on and on. Now notice anywhere I try to round off, it's going to go all the way up to 120. But what I'm saying to you, what if it was 119.1? The number of cups that would be completely full is 119 because 0.1 will be a fraction, a small fraction of that cup. But this is 119.99 and it doesn't matter how far I go, any attempt to work off will simply turn me into 120 because this goes on and on. But all the values will cause it to turn into 120. So therefore, 120 cups would be completely filled. Alright? Because there's no way to get this without rounding off, right? Approximately 120 cups. So anywhere you round off along the line, it's going to become 120. So 120 will be completely filled.